You wouldn't just be standing there, you'd have to literally wade through the air.
Like moving through a thick, dense fog. Unbelievable. And that's just the atmosphere. The planet's actual mechanics are just as strange.
You're talking about the spin.
The retrograde rotation. It spins backward. So for anyone there, the sun would rise in the west.
And it gets even weirder. A single spin on its axis, a sidereal day, takes 243 Earth days.
Wait, I always have to check this. Its orbit around the sun, is shorter than that.
It is. A year on Venus is only 225 Earth days, so its day is literally longer than its year.
How does that even work out for a sunrise to sunrise cycle?
That's the solar day. And because of the weird interaction between the spin and the orbit, that cycle is a more manageable but still glacial 117 Earth days.
And that slow rotation has other consequences, right? Like for a magnetic field?
A huge one. That incredibly slow spin is likely why Venus lacks a substantial magnetic field, which leaves its atmosphere totally vulnerable to being stripped away by the solar wind.
That lack of an internal engine seems to connect right to its geology, too. No plate tectonics like we have here on Earth.
Exactly. We call it a stagnant lid geology. Think of Earth's plates like vents on a pot letting steam out. Venus doesn't have that. The lid is sealed.
So the heat just builds and builds inside.
Until it triggers these periodic, catastrophic resurfacing events, the whole planet gets repaved in fresh lava.
Which is why the surface is so young, geologically speaking. Only about 300 to 600 million years old.
For the most part. But we do see these small, ancient, really deformed regions called tesserae that survived. They're like little windows into what the planet looked like before the last global reset.
It's amazing we know any of this. I mean, the only images we have from the surface are from the old Soviet Venera landers, and
they survived for minutes, an hour or two at most in that environment.
But the good news is that we are entering what people are calling the decade of Venus.
Yes, finally. We have missions like NASA's Da Vinci, which is going to send a probe right down through that atmosphere.
To sample it directly.
Yeah.
Look for signs of ancient water.
And then Veritas will orbit and use radar to create these incredible high-res 3D maps. It'll check for active volcanoes, shifting ground.
And if we just bring it all back to that scale analogy for a second, if Earth and Venus are, say, cherry tomatoes,
right, then Jupiter is a giant watermelon. It just reinforces how precious and similar these two small planets are.
So studying our volatile twin isn't just about Venus. It's about Earth's own future and how we judge habitability on planets way beyond our solar system.
It proves that just being the right size and in the right place isn't enough. So here's the thought I want to leave you with. If Venus once had oceans, what was the precise trigger? What was the tipping point that started that irreversible runaway greenhouse state? The answer to that question, which these new missions might find, will fundamentally change how we search for life in the universe.